This is number 15 of March 2021. First thing we do is read the question. When a buffet restaurant charges $12 per meal, the number of meals it sells per day is 400. For each 50-cent increase to the price per meal, the number of meals sold per day decreases by 10. What is the price per meal that results in the greatest sales in dollars? So after we read the question, we always ask ourselves what's being tested, and what's being tested here is a little bit of translation. It looks like we can take some of these words in this question and translate them into expressions and equations. And then, because we've seen questions like this once or twice before, we also know that they're testing quadratics here. We'll see how that plays out in a moment. So that's what the question is testing. What are we given? We're given a lot of information here. $12 per meal, selling 400 meals, 50-cent increase for each one of those. Number of meals sold per day decreases by 10. And what do we need? We need the price per meal. We're going to circle what we need. Price per meal results in greatest sales. So before we start, we should just point out, most students will understand this, but remember that sales, income, revenue, going to always equal price per item, and then the number of items sold. So price per item times number of items sold will give you your sales. So here's the ways that we could do this question. There's many ways we could do this question. One is a pure NITAS approach. We are being asked for a single thing here, price per meal. We have numbers down here in the answer choices, numbers in the answers. So we can use a NITAS technique. In other words, we can just plug in these answer choices for the price per meal and see what happens. So let's start that route. So remember what we do. We draw a T. We label the first column with price per meal. I'm just going to abbreviate. And in this case, normally on a NITAS question, we'd start at answer choice C. But because we have to maximize something here, we could start with D or we could start with A. I think the point is that we're going to have to go through all of these answer choices to find out which of these numbers maximizes the sales. So I'm going to just start at answer choice A. So let's say our price per meal is $16. What we can figure out from that $16 is how many 50-cent increases in the price per meal we made. If we go from $12 per meal to $16 per meal, that's $4 for total dollars, which means we have increased 8 times. I'm just going to draw a little up arrow here that will stand for my increases. We've increased 8 times. We could do this mathematically. We could do 16 minus 12 divided by 0.5. So that's that $4. I said we went up $4. We divide by 0.5 and we get 8. If you need to do the math, if you need to write down a calculation, great, go ahead. However, it's not too difficult to see that if you go from 12 to 16, you have made 8 50-cent increases. So now I know the number of 50-cent increases that I've made in the price per meal. And remember, every time I make one of those increases, the number of meals, so I'm looking at, let me slash my phrases here. So now I'm looking at this phrase here. It says that the number of meals sold per day will decrease by 10. So if I make 8 increases in the price per meal, then I am going to make 8 decreases of 10 in the number of meals sold. So that means I'm going from 400 down 10 times 8. Again, 10 meals decrease for every time I increase my price. So that is going to be my new meals. All right, meals here is going to be $3.20, which means my sales, remember what we said? We said sales is going to be the price per item times the item sold. So there's my price per item. There's my item sold. So I've got 16 times 320. Let me get rid of this math over here. 16 times 320 in the calculator. 16 times 320 gives me sales of $5,120. So remember, I'm looking for the price per meal that gives me the greatest sales. I don't know yet whether this 51.20 is the greatest sales, which means, again, I'm going to have to keep going here. So I go to $20, which is answer choice B. This was answer choice A. This is answer choice B. $20, that's an $8 increase from 12 to 20, which means 16 50-cent increases, 16 50-cent increases. So I'm going to do something similar here in the meal columns, except I'm going to replace that 8 with 16. So this is 400 minus 10 times 16, which of course is 160. 400 minus 160 is 240. I could do this in my calculator if I wanted to be really safe. I'll do 400 minus 10 times 16. I don't have to do any of this stuff in my head. I did get 240, so that was correct. So now I'm doing my price per meal times 240, and I'm going to go right in the calculator and I'm going to do 20 times 240, and look at that. My sales went down. So as of right now, this 51.20 is the winner. That's the greatest sales. So let me try to go a little bit faster for answer choices C and D. 24, that's a $12 increase. That means 24 50-cent increases. I'm going to do 400 minus 10 times 24, that's 240. This is going to be 160. Again, I could check that in my calculator if I needed to. That's 24 times 160. Let me find out what that is. 24 times 160 is 3840. I'm going down and down and down. Let's see if answer choice D pops back up for some reason. $28. So what is that? That's a $16 increase, which means 32 50-cent increases. 400 minus 10 times 32, that's 320. This is going to be 80. That means 28 times 80 will be my sales. 28 times 80, and that's going to give me something fairly small. So I can see now that I have maximized my sales when my price per meal was $16, which means my answer is A here. So this is pretty much a purely arithmetic-based approach. Obviously, you still have to read the question carefully. You still have to, interpret some of these phrases correctly and integrate these phrases correctly as you do on every single question, but a fairly simple, straightforward approach there. So that is the NITAS method. Now, the second method, which is going to involve some more conventional strategies and techniques, will be to derive the revenue function or the sales function. And the way that we're going to do that, so I'm going to draw a big line here to separate my work. I'm going to zoom out a little bit to give myself some more room. The way that we would do that is we're going to first let X equal the number of increases in the price per meal. So that was basically this column up here. We're going to let that column be an unknown. We don't know how many times we want to increase our meal, so we're going to put in an X for that number of increases. So the price per meal, so remember price per item or price per meal, so I'm going to write price per meal here. An expression for our current price per meal is $12, but if we want to express the price per meal with those 50-cent increases, what we would do is we would say that the price per meal is going to be 12 plus, that's the current price of $12 plus 50 cents times X, right? If X is 0, I'm just at 12. If X is 1, I'm at $12.50. If X is 2, I'm at $13. When X is 8, 0.5 times 8 is 4. 12 plus 4 is 16. So this expression right here is going to give me my price per meal in terms of the number of increases of 50 cents in the price per meal. In terms of items sold, in this case meals sold, I'll just write meals. The expression for the number of meals can also be expressed in terms of X as 400 minus 10 times X, right? If we increase the price of the meal by 50 cents, we make one 50-cent increase. In other words, X is 1. That would be 400 minus 10 times 1, which is 390. When X was 8, remember that our number of meals sold was 320, and that fits in this expression. When 8 goes in for X, we get 10 times 8 is 80. 400 minus 80 is 320. So 12 plus 0.5x over here on the left is my expression for price per meal in terms of x, and 400 minus 10x over here on the right is the number of meals that I will sell based on how many times I increase the price per meal. So this right here, this is my sales function in terms of the number of 50-cent increases that I make. So once I have that, there's really three ways that I could go. If you are very calculator savvy, probably the easiest way to go would be to graph this function. So what I'm going to do is I'm going to do 12 plus, I'm putting a parentheses around this, 12 plus 0.5x, end parentheses, new parentheses, 400 minus 10x. And I'm going to graph that function. I'm not going to see much because this function gets quite big. The numbers here are pretty huge. So what I'm going to do first is I'm going to do a zoom fit. So I'm hitting zoom. I'm going to scroll up until I see zoom fit. It's 0, so I'm just going to hit 0. And now I'm seeing my parabola. Again, this is a quadratic function, right? When I distribute, when I FOIL, the 0.5 times the negative 10x is going to give me an x squared. This is a quadratic function, which is why I'm seeing this parabola here. And fortunately, I can see this maximum point right here. So remember, because I have just graphed my sales function, right? I'm graphing my sales in terms of the number of 50-cent increases. That means that this function is modeling the sales. This function is telling me how much the sales will be. So if I go to this maximum point, which I'm going to do in a moment using the calculator, I will get my maximum sales, and I will also get the number of increases, the number of x, what x would be, to achieve that maximum sales. So here's what I'm going to do. I'm going to go second trace, which gives me my calc menu. I'm going to go to number 4, maximum. I am going to bound the maximum. That's what the calculator is asking me to do. It's going to ask me for a left bound and a right bound. This is all done in section 12 quadratics of the manual. I'm going to hit enter. When I'm to the left of my maximum, I'm now going to go to the right of my maximum. That should be good. I'm going to hit enter. So now I've captured what looks like my maximum between those two bounds. I'm going to hit enter again. And there we go. So the calculator is telling me that that maximum is going to occur at 8, 5120. Now remember what the 8 and the 5120 are. Obviously 8 is my x coordinate. And remember what x was. It was the number of increases of 50 cents in the price per meal. And the 5120, which is the y coordinate, but in this case it's s, it's the number of sales. That's my maximum sales. Having done the NITAS, some of this should make sense. I can see the maximum sales was 5120 and answer choice A. Obviously, if you're doing the calculator method without having done the NITAS, you won't have really any previous experience with these numbers, but it's nice to see that our numbers are matching up with what we did in NITAS. So there's the number of 50-cent increases. Again, that's what we had gotten up here, which means we are doing 8 times 50 cents, which is $4. That's the total increase over the $12. So I'm going to add that $4 to the $12, and I'm going to get 16. $16 will be the price per meal that results in this maximum sales, which means, again, the answer is 16. Now, listen, if you don't know how to use your calculator to produce that maximum, that's okay. There are other ways that you can do this. For instance, another thing that if you've watched the section 12 video, the quadratics video, you know that you can find your maximum, your vertex maximum of a parabola in a couple of other ways. We talked about how to find the maximum from vertex form and from standard form, and from, in this case, we've got what looks to be intercept form. So here's how we could do this. Now, first of all, we know without graphing on the calculator, we know that this will be a downward facing parabola, or should know that, because again, when we FOIL out these two terms, we're going to be multiplying this positive 0.5x by this negative 10x, which is going to give us negative 5x squared. So our leading term and our leading coefficient, we can see from that leading term, that leading coefficient, that this is going to be a downward facing parabola. That negative right there tells us this will be a downward facing parabola. So we know we're going to have a maximum. We know we're going to have a maximum as our vertex. And in order to find that maximum, remember that what we can do is we can average our zeros. We can find the average of the zeros. How do we find the zeros of this quadratic? We just set those two factors equal to 0 and we solve for x. So I've got 400 minus 10x equals 0 and 12 plus 0.5x equals 0. Subtract the 12, I get 0.5x equals negative 12. Divide by 0.5, I get x equals negative 24. My other 0 plus 10x. Let me move this calculator out of here. I get 400 equals 10x. Divide by 10. And what is that? I get x equals 40. When I average those two zeros, which I'm going to do in the calculator, negative 24 plus 40, and then I divide by 2, look at that. Oops, not by 8. I divide by 2. Let me go back up there. 16 divided by 2. I was thinking ahead to the answer. That's why I did divide it by 8. Got to be careful of that. So 16 divided by 2 gives me 8. So when I average these two zeros, I get 8. That means that I know my x-coordinate, so let's say one 0 is here, another 0 is here. Straight in between those two, I'll get the x-coordinate of my vertex. I know that that x-coordinate is 8. And again, that's what we've gotten several times already. There's 8, there's 8, there's 8. There's 8. So I really have just confirmed everything that we've already talked about. Once I know that my vertex occurs at an x value of 8, again, that x value was the number of increases. That's what we set out from the beginning, that x was the number of increases in the price per meal. And so I would do the same thing I just did over here. I would multiply the 8 by the 0.5 dollar or 50-cent increases. I would get 4. I would add the 4 to the 12 and I'd get 16. And then finally, one last way that we could do this, and this would require, again, being fairly calculator savvy. Once we get the sales equation, once we get the sales function like we did over here, we would punch that into the calculator. We've already done that, so we don't need to redo that work. And then we could use our table here. The way that we could use the table is, let me clear these out of here. Delete. How am I deleting this? What's going on? There we go. Delete. So I have my table set to ask for independent. The way that I do that is I hit second window, which is your table setup. Second window will take me into table setup. I have my independent set to ask here, which means that in my table, which I get to by hitting second and then graph, I can enter my x values. So once again, I have my y function. This is the sales function. That's what we wrote over here. This is the sales function. I have my sales function entered into my y variables. And now I'm going to go into my table. And I have an X column and a Y column. That Y column, again, is the sales column. And now what I'm going to do for each of these answers is I'm going to determine what X is. X is the number of increases. I've already done this work up here, so I don't have really any more work to do. For $16, the number of increases in the price per meal would be 8. So I'm going to type in 8, and I'm going to hit enter. And that 5120 is going to be the sales that correspond to a price per meal and a number of meals when I have increased the the cost of the meals by 50%. Geez, oh man. When I have increased the price per meal by 50 cents a certain number of times. So again, this is the number of times I have increased my meal by 50 cents, and this will be the sales that corresponds to the resulting price per meal and the number of meals that I sell. If I type in 16, I get 4,800. That's what I got there. When I type in 24, I get 3,840. And then when I type in 32, of course, I get 2,240. So again, what I'm doing here is I have created the quadratic function that models the sales. I have determined from each answer choice how many increases in the price per meal we have made, how many increases of 50 cents we have made, and then I'm using my table to type in the number of increases for X, and I am outputting the total sales that is basically the product of the price per meal and the number of meals sold. So multiple ways to do number 15, really depends on your level of comfort with translation, with quadratics, with finding maximums and minimums. I will say for a lot of students, the NITAS, the pure and simple arithmetic method, is going to be simplest here, but if you are interested in doing this question the more conventional or quote-unquote correct way or school way, then this stuff down below is really what we're looking at here. That is number 15.